Hey folks, is anybody there? Is this working? Is this thing on? I think I'm on. Just a sec. I always have to double check. I can never. Yeah, I'm on. Okay. Good to see everybody. Today we're going to be doing. Hey folks. Oh, is anybody there? That's me. Is this working? How do I turn on? How do I turn it off? I think I'm on. Oh, I have the watch page open somewhere. I always have to double check. I can never. Yeah, I'm on. Okay. I don't know where that's coming from. See everybody. Hold on. Today we're going to be doing. How do I turn this folks. Off? Oh, is anybody there? That's me. Is this working? How do I turn on? Oh my god. Okay. I think I'm on. Oh, I have the watch page open somewhere. I always have to double check. I can never. Yeah, I'm on. Okay. I don't know where that's coming from. See everybody. Hold on. Today we're going to be doing. How do I turn this folks. Off? Oh, is anybody there? That's me. There we go. I'm back. I don't know what just happened, but it was nuts. And I think it's over. It was very disturbing. I'm not happy about that. Can you hear me? Jeffrey Barnett, thanks for joining. Can you hear me? There we go. I'm back. Oh, it's happening. I don't know what again. Just happened. I don't know where this was nuts. Where this is coming from. I think it's over. It was very disturbing. I'm not happy about that. Can you hear me? Okay, I'm so confused. Like I'm trying to figure out where the echo's coming from. I've got I'm looking at a live stream page. Yeah, I don't know what that repeat. I'm not sure where it's coming from. That's really odd. I don't have any other Chrome page up. Just gonna give it a minute and see if there's another echo issue. I still don't understand what just happened. It happened twice after I shut down all my Chrome windows. But I think it's okay now. Okay, so I'm going to turn my desktop audio back on. I'm going to turn the music stream back on. All right. Very carefully turning things back on. Okay, I think we're past inception. So let's go back to what we were gonna do here. We're gonna work on active duty cycle. We've already implemented active duty cycles, but I didn't really do it well. So we're gonna revisit active duty cycles because we have to do overlap duty cycles. Hey, look, a formula. And I looked up in NewPick how they did duty cycles, and it was better than the way I did it, in that I don't have to keep a count of how many time steps, and it includes a period. I noticed there's a longer than normal delay. I don't know what to do about that. I have everything set as far as I can tell. Let me check my ingestion settings. I've got it set for, as far as I can tell, the quickest feedback that I can get. Sometimes there's just a long delay. I don't know what to do about that, so it will be what it is. It is what it is, which is the most tautological statement you can say. It is what it is, which means nothing. It means nothing. Okay, but the stream health looks good. We're going to talk about active duty cycles. Let's look at some code real quick, and I'll show you how I'm doing active duty cycles, or how I'm currently doing active duty cycles. So I'm currently, if you remember what active duty cycles is, you guys know what active duty cycles are? Do I need to go over active duty cycles? Because I'd be happy to. It's very simply, I'm keeping track of it as a percentage over time, as long as we've seen a mini column. Like from a mini column standpoint, how active has this been as a percentage? So 20%, if there's 100 time steps, if the answer is 20%, that means that mini column has been activated 20 times out of the last 100 time steps. So that's sort of a simple way of doing it. And we're calculating that once for each mini column. And we're going to try and do that a little bit better here. So the current way that we have been doing it is this way. So I'm keeping a count of how many compute cycles we've seen. So every time we compute, we increment that count. We create an output array, and that's one for each mini column. And then for each mini column, essentially, we're giving it an index of winners, the indices of the mini columns that won the last competition. And then we're just going to check if this one won. We're going to increment that count. And then, we've got two sort of things here. We've got this output array, which is a percent, and then the active duty ADCs indexed by the mini column index, which is a count over the past, over compute count, essentially. And this is the average. So this is how many times it's been active over how many computes we've actually done, and that's the poor person's way of doing the active duty cycle. Now that's different from the overlap duty cycle. So let's take a quick look at that. Oh, I shut Chrome down out of panic because of the audio inception that I had earlier. So let me just bring it back up. Dang. Okay, history. There it was. I was looking at the spatial pooler, and here is the actual formula it uses, spatial pooler uses. And here's where it does it. So there's a function called update duty cycles in the spatial pooler. If you guys want it to follow along with this, I will pop it into the chat. There we go. So this is a pretty good description. There's the overlap duty cycle. I'm gonna turn the music down a little bit because it's distracting me. I like a little bit of beat in the background, but not too much. So the overlap duty cycle is they're both moving averages, both moving average. Overlap is a number of inputs, and they're also both indexed by the mini column index. So for each mini column, we'll have an overlap duty cycle and an active duty cycle. So far, we've only done the active one. So the active one is the frequency of activation, which is the count, essentially a count of how many times it's been active over the period. Now in my implementation, my period isn't, it's basically is global. It's the total amount of computes. We really want a period that we can window in this. So that's one of our, go away. That's one of our issues in simple HTML, I believe. Projects, spatial pooling. No, did I? Okay, hold on. It's not simple HTML, I think it's in the actual, why did I put it in the wrong project. Spatial pooling. SP figure captions, permanent diagram, hover input, do not display. Where did I put this? Getters and setters, API change connection threshold, mini column boosting. Oh, there it is. Implement ADC window. That's basically a period. I'm going to call it a period because that's what it's called in the NUPIC code base, and I think mathematically that's what it is. It's a period. So that's what we're going to do. Let's just whoops. Why? We're going to move this in progress. So we're going to work on that, and we're also going to work on doing the overlap duty cycle, which I don't have a ticket for, but I'm going to do it anyway. Okay, so this is our way of doing it. The way we're going to do it is not going to be too much different, but we're going to abstract away a function so very similar to the way NUPIC does it. It has a helper that updates duty cycles. All it needs, and in this case, you can clearly see that when this is called, it's given the active columns, which are the winners, right? The winner columns, and we can assume that this active column, if we look at how it is used, it's this is Python and this is NumPy, whatever you want to call it. Hello, David Duckworth. Leona Duckworth's husband. Good to see you. I guess we could still, even if you're using your wife's YouTube, we could still do this live share thing, so let's do that. Sign in. I have to do this every once in a while. Okay. Are we good? Did it work? It worked. Copy. So anyone who wants to follow along, this is the simple HTML live share link. And that's all I've got so far. When we get to building HTML systems, we'll do that too. But we're going to start with the non-graphical stuff, and we're going to clean up our active duty cycles implementation and add an overlap duty cycle implementation as well. And then we're going to go add graphics for it. So I'm hoping I have to be done 3:30 at the latest. So I'm hoping we can get all that done. And if so, there's other things I want to do too. So, so without further ado, let's get to this. Let's first. I want to review this code a little bit closer. So when this is called, when update duty cycles is called, it's given an overlap. So let's look at see where it's called. Wait, that's not the function I want. I want this one. This is in the NUPIC code base. Here we go. So it's given overlaps, and I know what this overlaps is in active columns. Okay, I just wanted to make sure. So what we get here when we call this overlaps is an array indexed by many column index, and the active columns is I hate calling this a dense array, but it's an array of indices. So I think this overlaps is an array indexed by mini column index, and this, so we're going to have empties, we're going to have one for each mini column, and the active columns is not one for each mini column, it's just a list of the winner column indices. So it's these two things are different structures. Yeah, so and I guess I could just read this. And overlaps is an array containing overlap score for each column, and when it says column, it means mini column. We're talking about mini columns completely in this stuff. Okay, the active columns is an array containing the indices of the active columns. So what we get here is they're going to create an overlap array, and this is for the number of columns. This is just NumPy speak for zeroing out an array, creating an empty array full of zeros, essentially, for each mini column. Same thing for this. So they're creating these intermediary arrays, and then they're filling them with ones properly. So this overlap array is essentially putting in ones wherever there is any overlap. That's what this is. And this active array is filling in ones wherever, just for the winner column. So this is like a 1 and 0 array of active columns and overlaps. Okay. So the period is something we haven't set yet. Right now, the period for me is equivalent to, whoops, I'm in the wrong function, compute count. So we want to implement data structure. Jeffrey, I was thinking about your question there. If it depends on what code base you're in. If you're in Nupic C++, they do not have an SDR class. They use primitive data structures for SDRs. And if you go to the htm.core community fork of Nupic core, they have an SDR class, which has a lot of helper functions. Yeah, so I would look that up. In fact, I could probably point you in the right direction on the forum, because there's been some discussion about this. SDR class, and that would be in the community fork. Sparse distributed representation class. So maybe that's what you're looking for. And that is C++, if you're looking for C++. So that might help. Okay, let's get back to this. So, so this formula that we're using, so once we've got these things, so we're passing in the current, so we create these duty cycles, active duty cycles, overlap duty cycles, and basically we're setting them to ourselves. We're passing in the last value, and we're setting it to the new value. So what we get here, what we get back here is, well, let's go check it. Let's go look. And here's the function. And this is done, this has a little bit of array magic happening here because it's NumPy. So this is our formula that we're going to use, and this is essentially what I just wrote on the board. And I put some symbols in here. I tried to use the right math symbols. T is the period, and that's like the window of time that you want to do the calculation over. D is the current duty cycle, and X is the new input or new value. And if we look here, that's these essentially binary arrays that we're passing in. The overlap array and active array, it wants a binary array. So no dense, not an array of scalar values, well, 1 or 0, if you consider that a scalar value. So we're going to create a function that's similar to this. It's exactly it. It's a formula for running average. And we're going to do it twice, and we've only done it once so far. We did it for active duty cycles. It's essentially what I did here for each mini column, but I didn't use the formula that would include the window over which to run the average. So what I'm going to do here is, first of all, I have tests. So I'm going to look at the tests. I have tests for this. Unit tests, algorithms, ADC tests. All right, so, and all of it is with no window size. The values you average are 1 and 0. What we should get in here, we should get back here. It's different for, yeah. So you're right. For active duty cycles, it's ones and zeros. So that will give you a percent, something we can use as a percent, which is really close to what I'm doing here because I'm creating a percent here. But for the overlaps, it's not between 1 and 0 because the overlaps, I'm pretty sure they contain counts. I could be wrong about this though, because oh, they're not going to be counts. They're going to be percents. We'll see. Okay, we'll see. Oh, so what we're doing here is we're using a period, and this is iteration number is essentially what I'm calling compute count. So if the period's greater than compute count, we're set the period to the compute count, which makes sense. Okay. This is the thing that's confusing me. Is I know what this is doing. It's NumPy shortcut for saying do this over this whole array if the index if at each index oh wait a minute. Overlaps is an array containing the overlap score for each column. The overlap score is for a mini column is defined as the number of synapses in a connected state. So yeah, so we're just saying if the overlaps are greater, if there are more than 0 overlaps, essentially, we're going to set each index to 1, I think. I'm a little confused about how the overlaps is going to work, but let's set it up so the active duty cycles works, and we'll pull out like a helper function similar to what we did here that will do it, so that we can call it twice, once for the overlap and once for active duty cycles. So, and let's make sure that our tests run first of all. I think I'll just run current file. This should work. This used to work. 0. Wait, I have to select the tests. Okay. Okay, so tests currently work. For your period, is it the complete time frame of the recording, or does it remain a constant time? I want to be able to specify a period, and if there is no period specified, it'll be the complete time frame. Only if time remains constant is a moving average. Yeah. Otherwise, it's just a complete average. So right now, what we have is not a moving average; it's just an average, and we're going to convert that to a moving average. But first, I'm going to extract a helper function. I'm going to calculate this in a different way. I'm going to do it using that formula, right? So that, and then just make sure that it still works. So I'm going to say compute, just a compute duty cycle, and I'm going to make it look just like this one. I'm going to give it duty cycles, the new input, and the period. So that's what we'll say. Duty cycle, duty cycles, right? New input, period. And then that's what I want to, so I'm gonna comment this out. I'm gonna do this really carefully. So I'm not like a super fast coder. I'm just gonna, you know what I mean. Okay, this compute duty cycle. So we want to send it in the current duty cycles, which is this. That's our current duty cycles. We're always weighting the previous average by t-1 divided by t, and the newest values by 1 over t. Yeah, I think that makes sense. The new input is going to be the winners, but it's not, because I have to do this zeroing out type of thing. So const, these winners are by index, so I'm going to call this, let's call it binary winners. I don't have a better name for that. And then that's what I'm going to pass in. This isn't going to work right away. I'm just sort of setting some placeholders so I can get my logic right. And then for the period, we're going to use compute count because I want to see the tests pass before anything else happens. Okay, so, all right. And I will increment this here. We will be changing this so that it doesn't use compute count soon enough, so we'll get rid of this nasty inline incrementation. Actually, let's just do it right now. No, nobody likes that. It's much clearer if you do that. Okay, so so I've already got this winner indices. I've already done this, so I can take that and oh no wait. That's just the indices. So the winners map is not, it's a little bit more information that we need First, I'm going to get the indices, and then I'm going to loop through the binary winners. This is a little bit of overkill, I know, but I'm doing TDD, so we can always come back and clean up later. So please don't fault me for bad code. That's a great excuse, isn't it? Hold on a second. I gotta update this because this never works. Okay. I'm updating the viewers down there. Oh, there it goes. I don't know. I have to like manually poke that thing to get it to reflect reality. Okay, so for each mini column index, okay, we're going to set the bit to 0, and we're going to say binary winners push the bit. Okay. And if the MC index, it's basically the same thing I'm doing here. If winner indices includes MC index, if winner indices includes MC index, I'm just going to say bit equals 1. So I'm doing this ahead of time, and then that's what I'm going to send into the compute duty cycle. And then, I mean, this is going to be dead simple as soon as we get across the Eric says if you want to the average should be accurate during the early iterations, you would need to initialize t to 1. Initialize the period to 1, and increment it with each new sample until you reach your desired window size. Yeah, is that what they were doing here? So this is saying the period is the period if it's greater. No, that's so it's not taking into account whether if it's very small. So that's okay. But that's a good point. I think it'll increment pretty quickly. Usually the default for the period is 1,000. So we don't, and we don't usually. Oh, the number of samples. If you want, oh, okay. You would need to initialize it, increment it with each sample. Yeah, well, I think we'll get to that. So, okay, bear with me here. I'm getting distracted. So I'm gonna take this out because that's somewhere else. Our winner indices, and then I'm going to do the compute here. So the compute, now we're getting to the actual formula, which is that. So this is all it is if you're using NumPy, but we're going to have to do this for each mini column. This is like NumPy magic that returns an array because duty cycles is an array, new input is an array, I think, of the, new input is an array of the same type. So, so we're gonna have to do this because there's no JavaScript magic for us to do this. So we're gonna do the same deal. And I know this isn't like performant, but we're gonna do this anyway. We don't have to do that, we don't have to do that. So for each mini column, we're going to say our duty cycle, our new duty cycle, right, is, and again, it's our old duty cycle. So duty cycles MC index, looking at the thing, -1, friends, right, -1 times the, oh no, wait, the period -1, sorry, times the duty cycle. I got that wrong. So it's this is the old duty cycle times the period -1. Okay, divided by, and then we have the bottom of it, which is just the period. Okay. I think that's right. Duty cycles times period minus 1 plus the new input. I forgot to add the, I forgot to plus the new input. Plus the new input. And that's going to be plus new input at MC index. So this is for each. Let's split this. Yeah, this is okay. And now we can just say out.push duty cycle. Okay. So now we have this abstracted into a function that we can use for overlaps or active duty cycles. Trying to figure out where these my headphone cables should be. Sorry. Is this going to work? Let's see. I can just return this. Return this computation. Put the numerator in parens. That's a good idea. Okay. I'll leave it there. All right. Well, let's cross our fingers and run the test. See what happens. No, type error. Assignment 2. Oh yeah. So I've got a constant. Okay. How to go away? Go away. How do you go away? Hello. Okay. I'm still getting used to this IDE, so I obviously cannot have this bit be a constant. Okay, so let's rerun this. All right, so our assertion error. I really hate the way this displays, our tests display. So there's a problem with the compute. On third compute with first winners, the active duty cycle at 3 should be 2/3, but it was 0. So we have an obvious logic problem here. And that is, it got past, I don't want to step into that. I much prefer to see the test output in the console, honestly. But then it runs too much. So we have something wrong here. So let's step in and let's do a little bit of debugging here. Actually, let's debug into the test that failed on third compute with first winners. On third compute with first winners. On third compute with new winners. Oh, there it is. So where are we at? Oh, here's the compute. So let's stop right there. Let's stop right there. Oh, why is it throwing an assertion before? It's failing even before that. Well, that's good, because I was wondering how it got that far. No, this isn't where I want. I want to go here. Okay. So winners array, and I have a feeling this is usually just that the array structure is not what I need to enclose it in parens. The divide will happen first. Oh, is that it? Thank you. Hold on, I thought I did this. I've got this whole thing enclosed in parens. That's the numerator. All right, that should be okay. What did I do wrong? Put the numerator in parens. Okay, let's step through like we were gonna do. And I think it'll be obvious. Okay, step in the compute. He's right. Who's right? Okay, I'm not gonna, so I'll stop right here. and then go into this. So the ADCs is 0 currently, which is correct. And the binary winners, good, there's 2 winners. So, and their compute count is 2. So get into this. Going through each one here. So the duty cycle, so let's see, the duty cycle at 1, period -1, so duty cycles is going to be 0. I'm going to stop right here. Oh, you're both pointing the same thing. Okay. So the first duty cycle should be 0 because there's nothing there. Once we get to the third one, that's where I think we should, that's 1, round 2, our new input, index 3, sorry. Okay. Come on, index 3, are we on index 3? So this should be 1, should be +1. So our duty cycles of this one should be different, right? And it is 0.5. Oh, you want, I guess that's, I mean, this is probably just something I need to work out. I can get on Discord if you want, though. Discord, let me get you a, let me copy this, throw it in chat. If you want to join, I will open up the voice chat. And please remind me if I stay on voice chat, I forget about it because I tend to have a problem doing that. I forget I'm on voice chat. And actually, I have this thing, where is it? Discord voice. So it should actually show up here that I'm in voice chat there. So see right there, up on the top right, it says Rhyolite. So if somebody else pops in, I'll be able to, everyone will see who's talking to me, which is kind of nice. Okay, did I kill it? All right, I'm gonna step on through here because I want to see what out looks like. So it's 0.5. This seems right to me. Where is the test failing? On second compute with the same winner. So let me look through the tests and make sure that I'm I've got everything the way I think it is. So when there's no window, these are all with no window sizes. On the first computation, I'm basically saying, okay, the first winners are 3 and 7. I'm gonna write this down. The first winners, you guys probably don't have to look at this, but we've got 3, and then, hold on. I know this is kind of silly, but I'm gonna do it anyway. It's just how I work. 6, 7, 8, 9. So our first winners are 3 and 7. Our second winners are 4 and 8. Okay, so this is, whoops, let me do this in a way that I can tell how many cycles we've done actually. So second winners, let's do like this, X, X. Our second winners are 4 and 8. So that's after 2 cycles. All right, so on the first computation, back to my screen here. Shouldn't they be 1 at first? They should be 1. So on first, this seems to pass. On first computation, active duty cycle should be the same. That's not it. Winner indices for each ADC on first compute. Here's my compute. I'm computing the first winners. And then for each winner index, they should be 1 or they should be 0. So that's passing, I think. I think that was passing. Yeah, we've got 2 failing, and the first one is working. So it's on second compute that we're failing. Winner duty cycle at index 3 should be 1 on the second compute. So let's look at that one. If t is greater than 1 on first iteration, your average will not be correct. Well, t's always, wait. So you're saying this, on first computation, I don't have a t yet. I mean, I haven't implemented the period. I'm average, it's not a moving average yet. So just keep that in mind. The period that I'm using is essentially just the compute count or the iteration number. This should still work the way it's written, I think. On first, I mean, this does pass. So the way it is on first computation, let me just make sure. Yeah, this passes right now. So I'm not worried about this one. But I am worried about how many computes I've done. So I've computed first winners, and this passes. So it's the second compute with the same winners that fails. So with this one, we're going to compute the same ones, and this exact same test should be valid because it's the same winners. They should still be 100% on, but they're not. So let's stop here and look and see what the ADCs are. Let's stop right here and rerun. Yeah, second one keeps the same winners. This isn't what I want, where I wanted to stop. That's not where I wanted to stop. It's the second one. Okay, so we just computed the first winners for the second time. That's the problem. So 3 should be 100% and 7 should be 100%. So we're gonna stop right here. We're gonna see what we screwed up. So the new formula is screwing this up somehow. Can I not? Okay. Okay, so our winners are, I think it probably has to do with, oh, I know why. It's because we are no longer keeping track of the active duty cycles array. Oh, come on, don't do that. ADCs, right. So we used to update this .adcs and we're not anymore. That's why. So what we want to do is when we calculate this, we don't want to just return it. We want to say this.adcs equals and then return it. Okay, let's try that. Damn it, just run what I want, not what I tell you to do. All right, that one passed. And a third, okay, so we're passing again. The period is always the compute count or the iteration number. So it's gonna be always the amount of computes that we've done. So right here, I'm iterating the compute count before everything, right as we compute the active duty cycles, and that's what I'm using as essentially the denominator as the period. So I just wanted to extract this function so that we could reuse it for overlap duty cycles and have a way to inject a period if we want one. So now I'm going to write tests, that specifically set a period and make sure that they work. Okay. Okay, so the third, compute with new winner. So now what we're going to do is so I'm going to move this spatial pooler declaration into this describe function, and we're going to create a new. I'm going to basically copy and paste this because I want to run the same tests, but I want to run them with a period now. Okay, so with a period. And let's say with no period and with a period, so we're using the same terminology. Default. No moving. Not a moving average. I don't know. I just want to make sure people know what we're talking about here. A period, moving average. So let's say duty cycle period 2. Okay, so we're gonna keep this simple and low. Bye, Jeffrey. Thanks for joining in. We're gonna keep this duty cycle period low and simple, and I don't have to run the exact same thing. What I will do is I'm going to rename this to well, I guess first winners and second winners is fine. It doesn't matter. And then on first computation, this should all run fine as is. If I reran this right now, it should work. So let me just test that. Okay, just making sure. I mean, I'm not testing anything different. I am, however, so now I need to introduce this idea of a duty cycle period into the spatial pooler. Duty cycle period, and I'll just do it like this. Maybe not. Maybe I'll just keep it simple, and I'll only check the ops in the computation when I'm deciding what period to use. So here's where I'm using the compute count. So let's pull this out and say duty cycle period. Let's just say period, and we'll say period equals. No, this dot ops dot duty cycle period, or this dot compute count, and that's not going to work because it's going to be falsy. So I have to say if the duty cycle period does not equal undefined. It's a JavaScripty thing. If it's not undefined, then we're going to use it. Otherwise, we'll use the compute count. That's the best way to do this on 2 lines, I think, like this. So if it doesn't equal undefined, we'll use the duty cycle period. If otherwise, we'll use the compute count, and that will be our period. This should still run and pass. So let's test real quick that we run and pass. Nope. All right, so I screwed something up. Let's go to let me make sure. Let's go into the it call. Oh, I gotta stop here. First computation. Let's rerun this and dive into this and see why we screwed up. Diving in. All right, let's get to where we calculate the period to see what we screwed up. All right, let's go all the way here. Okay, is there a duty cycle period? Yes, so we should. oh, that's the problem. It's not going to pass because I passed it the period. So we're failing the right test. Okay. So that's good. That's good. So let's kill that. I hate dropping into assertion. This is the wrong thing to do. You do not, the debugger shouldn't drop into the assertion class, in my opinion. Yeah, so now we have to actually make this work because it's not working, obviously. David says you have to increase to that duty cycle amount. Right. Yeah, so we're not actually, we're only computing to use compute count until it catches up. Oh, I see what you're saying. Yeah. That's essentially what Eric was saying earlier, right? If the period is lower than the compute count, I'm sorry, if the period is higher than the compute count, I have to use the compute count, right? So we can do that. So let's do this a little bit differently. So let's say, first of all, let's just say period equals this dot compute count. First of all, if this dot ops dot duty cycle period does not equal undefined. Whoa. Sorry. It's not equal undefined. Then we're also going to say if duty cycle period is lower than the compute count, is less than the this dot compute count, then period equals this dot compute count, right? There's one way to know for sure, is to just run the test. Not quite, but this is a different error, isn't it? Assign it to a constant. Yeah. That's easy. That's easy fix. I've got the habit of making everything a constant, which is probably a good habit to get into. All right, rerun this. Yeah, okay, that was it. Okay, great. Okay. Now, so first computation. So I've only got this at 2. So of course I'm only running this twice. So now when we get to the third one, so first computation, first winners. Second computation, first winners. Third computation with new winners. So what I'd really want to do here is make sure it's not, so this is going to change, right? Or is it? Is it going to change? For the third oh yeah, so let me look back here. Third computation is the second winner. So the third computation is going to be this, or an 8. So if my period is 2, these should be 100%, and this should be 0. So I should do an assertion that index of 3 is, the ADC at 3 is 0. This is 100%. I've already got those 2 assertions. And 3 and 7 should be 0. Everything else should be 0. That is actually what I'm doing here. That's exactly what I'm doing here, I think. If first indices, else if. Oh no, I'm not. Oh yeah, no, I'm not. Okay, so this is the test that I have to change. So after the third computation, if my period is 2, which it is, then I'm gonna very explicitly do this. So let's do this explicitly. Like I said, I'm even going to, you might think this is ridiculous, okay, but I don't care. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to be super explicit about this. So this is I. This is 1, 2, 3. Those are our 3. So this is never going to have anything. On the third one, that's going to be on. On the fourth one, that was going to be on. That's going to be on. One day, someone might thank me that I did this. Okay, so after this, if the period is 2, just write myself some notes here. If the period is 2, after seeing the above pattern, we should expect, okay, so index 0 should be 0. 1 should be 0. I don't think I need, there we go. 2, 0, 3, 0, right? Because period is 2. 4, 100%. 5, 0, 6, 0, 7, 0, 8, 1, 9, 0. I know it seems obvious, right? But okay, so now let's just super explicitly do this. Let's do this. 4, 8 for each. These are the expected what should I call these? High ADCs, ADCs, something like that, for each one of those. So what I want to do is assert that all of these are 1. It's not going to be, it's going to be a complete equal, and I'm going to get ADC let's just call this index, let's just call it I. Okay, the ADC, that should be 1.0 period, and we'll put a long description as in the template and say for period of 2, last 2 cycles of index should have been on, so ADC should be 1.0 when period is 2, because I explicitly set that. Okay, and then I'm going to do the same thing with the other indices and just assert that they're 0. Off. Hello, Mark Brown, Kingston, everybody. 0, 1, 2, 3, 5, 6, 7, 9. Everything but 8 and 4. Okay. So should be 0 and period is 2. Okay. Let's see if that passes. Yeah, it's not because I didn't program it to work. Okay, so let's go into this and actually dive into the compute here and get into this compute. This can go away. Okay, over. Now the problem is going to come when we get to the period here, right? So let's dive past this. Okay, so we're setting the period to compute count, and if the duty cycle period is not undefined if duty cycle period is less than the compute count, which it is. Oh, see, that's not right. I don't want the period to be the compute count. That's failing. If the duty cycle period is more than the compute count, right? That's the problem I had. Okay, let's try this again. I didn't. All right, dive in there. All right, let's see this work better, hopefully. All right, so our duty cycle period is not, it shouldn't be 3. Greater than the compute, how did this become 3? Oh, I know. I didn't put an else. I didn't put an else in here. Or actually what I should do is set this to, let's just say let period. Let's just be very explicit about it. Else period equals set ops duty cycle compute count. All right, I'll bet you this will work. I bet this will work. Let's rerun it. Damn it. Damn it, it didn't work. Okay. Why the hell? I wish I need to be able to tell it somehow not to break into the assertion. It should default to the test assert. Oh, we've got an error on the first computation this time, so let's stop in here and figure out how we broke that. Dive in, close, and it's going to be here. Okay, so our duty cycle period is undefined. Oh, right. So I do want to set this. I will set this to this dot compute count. And, okay, I'm gonna say less than, or get rid of this. Okay, that's gonna work. Okay, would that clear the others to 0? I don't know. I'm afraid that like your chat is so far behind me, I'm off to something else. Okay, let's try this again, because I think we're almost there. Been going at this for an hour. Hopefully we'll make some fast progress once we get this put in place. Another assertion error. But we're in the right place anyway. So let's look at the ADC. Oh, I know what it is. ADCs. No. ADCs. I think I might have a problem with my test here. Yeah, so I'm looping through the ADCs, but that's not what I want to do. I don't want to do this. Okay, so I was looping and now I'm manually doing it. So it's ADCs at index, ADCs at index. Okay, let's try that. Oh, that's a debugger. Okay, we got to our third compute. So close. Type error. It's not a function. I can't do an inline for each like this. I swear I've done that like a million times. Maybe I just have a syntax error somewhere. Hi, what am I coding? I am, so I'm creating, and I'm doing active duty cycle implementation for a spatial pooler. And if you want to see exactly what's going on or what I'm working on, let me show you real quick the application spatial pooler. Here's the page that I'm working on directly. And at the very bottom is this active duty cycles. This is what I'm working on. The active duty cycles for an HTML spatial pooler for this document. It's a tutorial on spatial pooling. And so if you want to understand what I'm doing, you can read through this document. I'm building it out as we go. A lot of it's empty, but I'm working on the spatial pooler section right now. And this code is going to run these diagrams. So these are all dynamic diagrams. It's actually running spatial pooling in the background. And I'm trying to properly calculate the active duty cycles for each mini column, both active duty cycles and overlap duty cycles. So if you want to try and understand what those means, read this document or go to our forum, HTM forum. Or watch HTM School, which is there's 2, 3, 4 episodes on spatial pooling. But that's where I'm at. I'm deep into the active duty cycles part of this, and there's something silly. I know there's something silly here that I'm doing wrong. Mark Brown hates off by 1 errors. Every programmer hates off by 1 errors. So I don't understand why. Maybe this is a Python thing that I have to declare this. Let me try something. I'm so bad at JavaScript. There's a for each. 1, 2, for each is a function. So I should be able to do that. Why can't I do for each here? I feel like there's some missing some syntax error somewhere. I want to put this comment back in before I lose it. Not that. This. Yeah, that's what I thought. So what's the? Okay, let's just pause right here and go back and debug. Can I get through this? Step over? No. Type error. SB compute active duty cycles. So that doesn't make sense to me. Why is it calling it compute active duty cycles when something's wrong here? Like it thinks that it thinks this is a continuation of the previous line, but it certainly isn't. Is it because, no. So let me just test something. On. Let me try this. If it's fine with that. Oh, now I have an assertion error. So that threw me. I don't understand why that happens. The for each in your method. The for each in your method. Oh, wait. The for each in my method. What for each in my method? I don't have a for each in my method. I just have an assertion. See, when I did this, it worked. You don't need it anymore, but I use it. Oh, I need a semicolon? Oh man. Frickin' semicolons. I tried to not use semicolons anymore, because I thought it would be a good idea. Okay, keep going, keep going. So I am getting an assertion error now. Right, this is a valid assertion error. This is a valid assertion error. Okay, so let me run this. I'm gonna run this and let it go, let it go. I wanna see the error. Okay, so I got just one failure. The second compute with the same winner, so we're on the third compute with new winners. Last 2 cycles of index 4 should have been on. So ADC should be 1 when period is 2. Right, so we're getting failing right here. This should say so. All right, so this is a valid assertion error, or a test error. So let's stop right here and run our debugger again. Dive in. Hopefully I can get past this and we can work on, let's make sure that our period is getting set right, because that seems to be the crux of all our problems. Okay, so we're using the duty cycle period because it's less than the compute count, which is right. Now, the binary winners we're setting in is 4 and 8. Are those duty cycles a real thing in the brain, or you just made them up? Sorry, I'm new. It's for implementing boosting. Let me give you a quick link to boosting.
Well, it's been a while. Perhaps you need a little boost.
This is
you'll
this is the boosting episode. So watch that. And there's also, I think, stuff about that talks about active duty cycles. So yeah, I'm not sure if there's a direct correlation to active duty cycles in your brain, but this is a way to enforce homeostatic regulation of neurons. So that's why we're doing it. We're sort of doing a computer sciencey thing to try and simulate homeostatic regulation of neuronal activity. In the fewest words I can use. Okay. Where was I? Okay, so I want to confirm this .adcs. The last one, we're 3 and 7 we're on. That's correct. Our current winners are 4 and 8. Oh, so that's wrong. Current winners shouldn't be 4 and 8. Oh yeah, it should. If this is the second. No, this is the third. So the last ones. So I think I see what the problem is. The current ADC, where are we at? We're right here. We're about to go in. So this is before computing the third compute cycle. Our ADCs should be 4 and 8, but they're 3 and 7. So something happened here in the cycle before. Hey, thank you for the follow, Logan Dunbar. That you didn't expect that to happen, did you? I guess it's not a follow; it's a subscription. I'm on YouTube now, not Twitch anymore. So we're really close to having this work. It's just there's something wrong with this ADCs. Here's what I'm going to do. I'm going to stop right here on every. I'm going to rerun it, and I'm going to pay close attention to the compute cycle. Let's open this up because I want to see what I don't care about the call stack. I want to see the watch. So this dot compute cycle. Compute count. Oops. Compute count is 1. Okay. Our current ADCs are all 0. Correct. Okay. On the next one, we're at 2 now. We saw 3 and 7, which is right, which is what we expected. And our next ones, our next winners should be 4 and 8, and they are not. Okay, so what happened there? Okay, stop it with the mouse overs. The binary winners should be 4 and 8, but they are not. It's because I'm sending in the wrong winner indices. Hold on. Let me go back to the call stack. Oh, right. Oh, I'm sending in the first winners twice. Okay, so, but in my test, I set up to send in the second winners first winners, second winners, second winners. Okay, so here's the first computation. And this should be second winners. Okay, and then on the third computation, again, second winners. That's what I described here. This is the first winner, 3 and 7. Whoops. All right, and the second winners are the next two, 4 and 8, 4 and 8. Okay, let's try this one more time with feeling. Okay. Another assertion error. This time, David says, do you want a greater than? Well, greater than, excuse me. When I'm deciding the period, you mean here? Well, that's the only place I can think of. If the duty cycle is greater than the compute count, we don't want to use the, no, I think this is right. We want to use, maybe we want, if the duty cycle is less than the compute count, we want to use the duty cycle so that we have the rolling window. If the duty cycle is greater than the compute count, we have to use the compute count. So I guess we have to do both, right? Else, and was, but I'm already setting it to the compute count, so I shouldn't have to do this. But this seems right to me. If the duty cycle period is less than the compute count, that's our window. So we want our period to be smaller than the compute count. That's fine. Because the compute count is just going to keep going up and up and up. But if our duty cycle is greater than the compute count, it's going to be set to the compute count, which is right. It seems right to me. All right, let me see where. Let's go back here. I don't want to dive into the assertion class. All right, I'm gonna go back and I'm gonna dive in here one more time. Stopping here. Okay, so we're on the same page. Second compute, same winners, right? 4 and 8. Current ADCs. And now we're going to go into the function. So here we're doing the computation. It's okay. You don't. I'm doing fine. We'll get this one way or another. Honestly, it's just programming is tedious, Falco. It's just we're gonna go through this no matter what. Okay, step. So our compute count is currently 2. We already know our winners. Winner indices are 4 and 8. And this is our second compute, which is right. Okay, second compute, 4 and 8. Our previous ADCs should be 3 and 7, which is right. Okay. So let's go down to the period and make sure we're getting the right period. Okay. So we're going to set it to 2, although it's... Oh, I'm in the wrong test, aren't I? Yeah, I'm in the wrong test. Damn it. I should have thought I had this zipped down. The test I want to jump into was the one that was actually failing, which I think was here, second compute with same winners. No, it's the first test I've got failing. Okay. Okay. So maybe everything works now, except for the first test is broke. Or not. on first computation wins. Second computation with same winners fails. When calculating active duty, with not a moving average. Okay, so we want to go second compute with the same winners and not a moving average. Okay, so I broke something. Stop that. I broke something in this first one on the second computation right here. So we are going to jump in there. I thought I was in the wrong place, but it turns out that is exactly where tests were failing. So dive in here. Let's look at the period. I have a feeling it's going to be something to do with the period. Binary winners are correct. Previous ones, right? Our winners are 3 and 7. 3 and 7. Compute count is 1. There is no duty cycle. It's got to be something with the period. So the period is going to be 1. So that's I think this is what Eric might have been talking about earlier, Eric Collins, when he's saying when the period is very low, it could be because the compute count is very low. So let's dive in here. Just make sure I know what I'm sending it. I'm sending it current ADCs of nothing. See, that's a bit suspect. That's a bit suspect. Because the first test, are we still on the first computation? I don't think so. We are on, oh yeah, we are. We're on the first computation. So I actually put this in the wrong place. It's the second computation that I want to go. Because this one passed. Okay, so that one passed. So now we're on the second computation. Sorry. It's confusing. All right, so the winners at this point were 4 and 8, which is correct. Those were the second winners. Our ADCs should be 3 and 7, which is right. So that's the last winners. Okay, the period will be 2 because there's no active duty cycle period. All right, so now we're going to do compute the cycle. Here's the current ADCs, which are 3 and 7. Here's the binary winners, which are 4 and 8. And the period is 2. Okay. Everything looks good right now. So compute count is 2. The period is 2. This looks right. Okay. So we're going to go through each mini column. I'm just going to watch this happen for MC index 3, because that was the first one that have a value. Okay, so for 3, duty cycles at 3 is currently 1 times the period, which is 2 minus 1, which is 1. So it's just 1 plus the new input, which is nothing. Okay, divided by the period, which is 2. So it should be a half. The duty cycle should be a half. And it is a half. That makes sense. Okay. Okay, let's step out of this. Let's get right here and make sure now that we've got our out. This is correct. The problem is my spatial pooler that I'm using does not have a specified active duty cycle period. So why is it compute count is 2? Yeah, that's right. That's right. That's totally right. Is my test wrong? I'm wondering if my test is wrong. I really hate redefining my test when I thought something was working, but on first computation, this is correct. On second computation, this doesn't seem right anymore. Oh, Jesus. Okay, this is first winners. I think I did the wrong thing. So I got my two tests mixed up. The first test was supposed to be, the first one meaning not a moving average. It sends first winners, and then it sends first winners again on the second computation. And on the third computation, it sends the second winners. Okay? Now, when there is a moving average, it sends first winners. But it doesn't send first winners again, it sends second winners. So I changed the wrong one. And then it sends second winners a second time. First winners, second winners, second winners. Oh, okay. It's driving me kind of crazy. But it's better to find this stuff in your tests than not find it. Okay, so I got through all the way to the second computation of the moving average test. That's good. Okay, so let's set our breakpoint there. Rerun, dive in, and see what's wrong with the period, because it's always the period. Okay, so the compute count is 2, but we also have a duty cycle period, which is the same. So it doesn't matter, it's going to be 2 no matter what, right? The period's going to be 2. Our ADCs are 3 and 7, right? This is our second one, and our winners are 4 and 8. All right, so this is where I've got my test wrong, I think. Yeah, our winners are 4 and 8. And I'm pretty sure that I have my test wrong here. There's don't talk like that, Falco, please. No, I've thought the same thing. You know, you end up having, if you're not careful, you end up re-implementing the logic you're testing in your tests, which I have done before. Okay, so this is wrong. On the second compute, if we're going to pass the second winners in, okay, I'm going to be, again, very explicit about this. Because now we're running with, maybe I don't need to be. All I need to do, yeah, I do. Yeah, let's be super explicit about this once again, once we've done this. All right, so there's no third yet, but this is correct. We should expect now 3 should be 0.5, 4 should be 0.5, 7 should be 0.5, and 8 should be 0.5. So let's just do basically the same thing that we did here, but for different indices. Okay. So this is going to be 3, 4, 7, 8. All should be 0.5. Everything else should be 2. Or 0. Everything else should be 0. So 1, 2, not 3, not 7. Everything else should be 0. Okay. Deep breath. Run the tests. Deep breath and run the tests. Okay. Keep going. Keep going. Ah! Type error. Okay. Semicolon. Try again. Man, I gotta remember that. Stupid semicolon. Another type error. Another semicolon. Right? And I'm sure there's going to be yet another semicolon here. Okay, try again. Good grief. Okay, second compute with same winners. So it's not getting a 1 here. Basic step in troubleshooting electronics is check the tool for same response. Yeah, that's the, same thing with audiovisual stuff. Check the cables. Check all the cables any of the cables could be failing. I learned that pretty quick. It's so frustrating when it's just one of your umpteen cables is failing. You don't know which one it is. Okay. Okay, so we're on the third compute here. Third compute with new winners. We're sending in the second winners. Again, the second time. So this should be right. And if the period is 2, we should get 100% for 4 and 8. Just like we have here, 4 and 8 should be 100%, and everything else should be 0. So if that's not happening, we got problems. And it's not happening, obviously. So here, ADCs is, yeah, so it looks like it's 3, or the period is wrong. So the period is wrong. All right, one more time. Debugging. Hardcore debugging. One more time. Let's see, why is the period bad? Let's confirm that it's the period. The period should be 2. It is 2. It is 2. I'm sending in... Oh. Oh. Oh, there's something wrong with my computations, isn't there? Hold on a second. Yeah. So let me put a conditional break in here, and I want to stop here if period is 2. So I want to see what's going on here. So our last duty cycle, I think my formula might be wrong. Our last duty cycle was 3 and 7. How will it clear the others back to 0? That's what I was just thinking. Let's take a look at the formula. This is the formula I'm essentially, and I'm not doing this assertion, but oh well. So this duty cycles an array containing 1 or more duty cycle values that need to be updated. 1 or more. So I may be confused about what this duty cycles value even is. A few iterations. I mean, it should be able to think through this even with a small number of iterations and just manually, do the math. And what I'm confused about perhaps is what is being calculated here. Like, okay, what is the initial value of overlap duty cycles, for example? Let's do active duty cycles. Let's see if we can find this. Okay, so it's zeroed out by column, mini column. So it's just 1 0 for each column, which is sort of what I expected. And that's what I'm doing. So my duty cycles are 1 for each mini column. And what this function does is the duty cycle is a scalar value now. Maybe it's the new value. It's the new value, whatever this new input is that I'm screwing up. A new numerical value used to update the duty cycle. So 1 for each mini column that will be used to update the duty cycle. So this should be scalars. And what are they in mine? Repeating input drive the winners to respond first. I don't think I'm even to that part yet. All I'm doing here is just trying to compute the moving average. You have a stack of previous overlaps that I limit to a period size and average them. Yeah, that's what I thought to do first, but I wanted to try and do it the clever way. My new input, I think perhaps the let's see. I'm calling this binary winners. Okay, let's take a look real quick about how this is calculated again. The new input, or what would be the active array. So it is a binary array. The active columns are an array containing the indices of active columns, a sparse set of columns which survived inhibition, the winner columns. Now they're not, I'm sort of using the wrong terminology here because this is sort of deciding, we haven't decided the winners yet because boosting gets involved, but they're the active columns that survived inhibition, indices. This NumPy will convert this, because here we're getting zeros, all zeros, and then we're just setting the bits that match the active columns to 1, which is essentially what I've already done here with these binary winners things. You know, this is all basically that one line of NumPy. So I'm just going to figure out, is my expectation wrong? I don't think so. This is still our first computation. Period is 2. Oh, wait a sec. Wait a second. Not sure how you would get the 0.5 to 0 with simple period divide. Yeah, but I know this works. Like, I know this works. I mean, I've seen it work. It's like tested the hell out of it, and I've made visualizations using this exact code to create the duty cycles, both active and overlap. So I know it works. I've just got something wrong in my head somewhere. Let me just think through this. Over the iterations, the moving average would be different and using compute count, but not sure how it would go to 0. Yeah, I agree. It's like the period, the duty cycle period here seems special. Let's go down. The period of the duty cycle. And period, I know, is just a number, an integer. So this confuses me. Why is this a decimal value? That seems odd. Usually when you specify a decimal value in Python, it's just to indicate that the number you're you steal my code once it's working. That's fine. That's fine. Once it's working is the key phrase. Let me just keep debugging. keep debugging here. So I've got my winners, 3 and 7. The current ADCs are, come on, 3 and 7. This is our second pass through. It's 3 and 7. The old the old duty cycles were 3 and 7. This, yeah, remove it. So here is where we're still in the first freaking test here. This was passing, wasn't it? It's the moving average that wasn't passing. That's this second computation that wasn't passing, right? That's the one. Everything else is working. Here. All right, so. Okay, so let's go into this. We're computing with the second winner. So we already have, I've got a new spatial pooler. Our winner indices are 4 and 8, and our current active duty cycles are correct for the last pass, but you're right, how did they get zeroed out? Oh, wait a sec. Wait a second. Every time we call these, overlap array, active array. I'm just wondering if there's anywhere we're messing with these. So we're messing with boosting, that's boosting. That's serialization. This is instantiation of the spatial pooler, I believe. Yeah, that's the init. So it's instantiated to zeros. Get active duty cycles. This just writes them. That's different. That's nothing. Strip unlearned columns. That's not what I'm. Update min duty cycles local. That's for local inhibition. I'm not making nearly as much progress as I wanted to make here. So I just need to take a deep breath. But once we get this, we can just do the same thing for overlap duty cycles, and we'll have that working. But I wanted to get this function running without keeping a whole 1,000 array list of every many columns overlap and active duty and activity, which is just going to balloon, hugely. And I saw how it worked in NuPic, and I thought, oh, that's clever. It's just a moving average calculation. You know what I could do? No, I don't want to do that. So duty cycles need to be updated, 1 or more duty cycle values. Here's what's confusing me. 1 or more duty cycle values? What does that mean? 1 or more duty cycle values? I don't think it's correct. I don't think it's correct. If it were correct, for example, I'm on my third compute, and I mean, these tests seem right to me. If the period is 2, this should be 1, this should be 1, everything else should be 0. But that's not what's happening. And you can see why right here, because we're looking at the active duty cycles. We're right here. Right here, where we compute this. We're sending in active duty cycles that have these 0.5 values, because that was the last ones that we had. Those were the last values, which were right. I just asserted against those. But how does this moving average formula possibly work? I don't understand how it will work. This would keep the wait, unless you put a value on each column and run your filter on each position. That's what I would start with. This would keep the size of the data array linear with the data array size. Well, I'm putting a value on each column, but I'm trying to keep it to one value on each mini column, not an array of activity. It's almost like I think what's happening here, whatever this is doing, whatever numpy is doing here, it's doing something extra that I'm not incorporating. So one thing I'm missing is there's no return value described in this. Yeah, that's the thing. Yeah, to cancel out the values outside the window. That's the thing. And how do you do that? For each, how do you do that in this? Let's go into here. It's got to be something I can do right here. I feel like numpy's doing something extra that I'm not, and that's why this is working, because this is an array, this is an array, period is not an array, but duty cycles and new input is an array. Duty cycles is what I'm confused about, is because I don't know the dimensionality of this return value. It looks like it's just a one-dimensional array of numbers between 0 and 1. So, which is the same as duty cycles, because that's the same. That's what gets passed in, and so returning a mutated version of that. Well, a copied and changed version of that with the same dimensions. New input should be the same dimension as duty cycles, but here's what confuses me. For duty cycles, it says an array containing one or more duty cycle values that need to be updated. One or more. That's what I don't get. One or more. It's one, the way I'm using it is one duty cycle value per mini column. But maybe that's not, that certainly is what it seems to be. Because if I look at what we're passing in here, the overlap duty cycles is zeroed out to 10 per mini column. So that's initially what it starts out as. I'm looking at the wrong one, but it's the same thing. This is the dimensionality of the mini columns. It's this one number per mini column. Yeah, you add the current reading and remove 1/10 of the total, and that's really what this is supposed to be doing. You add the current value, and is my order of operations wrong here? Let's go all the way into this function and see. So this is for index 0, which is nothing, so that's boring. 1, 2, 3. So now we're in the right place. It takes 10 cycles to fill the buffer. But where are you getting the 10 from? Because there's 10 mini columns? I'm doing this calculation once per mini column. So the buffer's only 2 long because the period is 2. That's the window size. And I'm dividing by the period. So duty cycles at index 3, which is 0.5. Which reflects the first input that we saw. That's outside of our period now. That's the thing that I don't get. It's outside of our period now. I might have to talk to somebody in the office about this. Because I'm totally confused. This seems simple, but I'm missing something here. I mean, I can see what's wrong here because this value, this 0.5, should not be represented in the moving average anymore. Yet it is, right? Nope, in the on column, it takes that many updates to get the averaging to work right. So, if that's the case, I could, but why does it take, why is 10 a magic number? Just to, why, in the one column, in the one column it takes that many updates to get the averaging to work right. Oh, I think I see what you're saying. And this is again what Eric Collins was saying earlier is that we need to see more. Oh. All right. Okay. So what do you think about going to my tests and trying to define some tests where I send it a bunch, like a lot more. Like maybe I'll send the first input 100 times and the second input twice, and then assert that we're only represented those last two. I think 10 in his example from earlier in chat. 10? Do you think it takes us 10 cycles? Okay. All right. So let's try that. I'm gonna take your advice. So I'm going to rolling average with a buffer size 10. Since you divide it by 10, you have to fill the buffer with 10 samples so that the buffer size has X readings. But okay. Maybe I'm missing something here, but I don't know where you're getting the 10 buffer size. Is this just a thing about rolling averages that you need more samples for it to make sense? All right, first winners, second winners. So let's start kind of fresh here. Oh, I broke something. Okay. Let's send it. So you can could set the period to the number of samples that you have fed in. If the period is that's the same thing as not setting the period at all, which is what I've done, which is the first test. So if I do like, let's say I do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is silly, right? But I want to see what happens. So then I send second winners in twice. Oh, well, my rolling average is 2. So it should, and it's on the third computation, you know, that I've moved along. Let me just see if this works, because I'm not sure if I understand. I just want to see what this does. ADCs, so we'll do so what I should be able to assert here is essentially 4 and 8 are 100%, and the rest are not. The rest are 0. That's what I would expect. Basically, this assertion, if I've done this correctly. Oh, semicolons. Yeah, I understand. It's a pain in the ass, I know. Okay. So what are my ADCs here? So this is still wrong. It's still retain. What? That doesn't even make sense. Hold on. Hold on. You're just gonna have to watch me bumble through this, you guys. I want to watch as this happens. I want to watch and see what the ADCs are. Go away. Okay. 100, 100, 100, 100, 100, 100. That's good. That's right. That's not. Okay, hold on. Let's try this again. Okay, that's right. See, this is... So, I see what you're saying. This is exactly what you predicted, right, Mark? So, I basically have to give this time to average out, I guess. On the first one, or half, this makes perfect sense, because we've got the first winners and second winners half and half, and then we step forward again, and the moving average takes a while to adjust. So this is what you're expecting, I think. I didn't realize that moving average formula would do that. I mean, you guys all told me that. Eric told me, Mark's been trying to tell me. I don't like that at all. It sucks. I mean, the thing that I want to do is the thing that would make sense, but is too prohibitively expensive, I think, is to keep track of every mini column's last activity and overlap for the duty cycle period, which is the number of mini columns times the duty cycle period scalar values, which duty cycle period is generally 1,000, so it's 1,000 times the size of mini columns. And the same thing for overlap, so 2,000 times more memory than this method, which I don't really want. There are other types, other filter types that have different properties, but this is a good filter type and you can deal with the delay properties. Yeah, it's an exponential settling shape. Okay, well, I mean, it's probably fine, honestly, for doing for applying boosting, because it just means that your initial values aren't as accurate as they will be after it's seen a bunch of data, right? So look at the NumPy code, understand the lines up above the call to update the duty cycle. You're talking about this stuff. Yeah, I think I get it. I was just hoping that wasn't the case, but it's just, I guess I thought there was something magic because I didn't quite understand the update function, but it makes sense. You could do the calculation as many times as the period. Yeah, I guess, but that seems almost worse than just doing one average across. I'd rather have more memory than more calculations, I think. All right, see you, David. Okay, so I want my tests to pass. I want to have a test that makes sense. I don't know if this makes sense or not. What I could do is say close. I mean, this will get it to pass, and it's now what you guys have told me I should expect. I think this will make it pass if I just look for close to the value after I do this. Let me take this off. It's a ugly, ugly test, but whoops. Ugh. Wait a minute, what? Close to. Okay, Eric said scroll up. You mean where it's being called, right? Which is here. This stuff. Overlap, or activity duty cycles is moving average of the frequency of activation for each column. I thought I understood this stuff. At least I understand the data structures that are being sent into it. Understand the lines up above the call to update the duty cycle where they set the period. where they set the period here. This stuff. So if the period's greater than the iteration number, then we set the period to the iteration number. And here, I say if the period is less than the iteration number, period equals duty cycle. Oh, so they're doing it sort of different than me. Okay. Do you think this is... Yeah. Got it. This is different than what I'm doing. I'm doing it sort of backwards. So I could definitely fix this. We could say let period equal, in this case, this.ops.duty cycle period. And I have to check to see if it's undefined. If it's not undefined, then oops. Otherwise, this.compute count. It's long, ugly, I know. Okay, that's essentially setting it to the duty cycle period. And then if it's greater than the iteration number, if period is greater than this dot compute count, we set it to the compute count. Okay, so that's simple. Okay, I'm gonna try that. Okay, this should still pass. It did. Now, it's not gonna help me with any of these other tests that I wanted to pass though, right? Yeah. We're still failing on the first computation. I didn't expect to fail on the first computation. Typically, okay, let's watch it. I'm gonna watch it. Refresh. So they set it to the window size, unless the current iteration is less than the window size, then they set it to the current iteration number. Period is the number of samples. Now your test should be number of activations divided by number of cycles. Oh, hold on. So for example, so this isn't, well, this should still work. All right, I'm gonna go into this and try and figure this out. Here. Okay. So this should set it to 2. And compute count is 27. That's, wait a minute. Oh, right. Okay, I can't. I forgot I need to not do this now. This kind of breaks everything when I do that. So let me just turn that off and first computation, it worked. Wait a minute, did that really just work? Did I really just get what I wanted to get? No, I have the assertions commented out. I thought for a moment that it worked. Okay, this isn't where I want first computation. Hey, it did work. That worked. Hold on. Eric, I think you just, that's what I wanted. Yeah, this is right. It worked. All the rest are 0. Holy crap. Okay, let's see if the bottom one works. So it was just my period calculation was off because I wasn't following the right code. Oh man, if this works out, I'm gonna, oh shoot, what happened? Okay, so what are the ADCs here? Yeah, so, well, this is the same issue I was running into earlier. So it didn't actually work. I mean, it didn't make it work the way I wanted it to work. It just is working the way you guys told me it would work. I still, so in this case, I'm not sure, but I have a feeling that maybe the way I was doing period was just a backwards way of doing it the same. That certainly works, but this certainly is not what I expected. So I want to update the test to what I would expect. So, and so what we're getting is a 0.25 and 0.75 here. My window size is 2. Right here, I set it right here. Duty cycle period in the beginning of the second set of tests. I create a new spatial pool there. Set duty cycle period to 2. Not even using that or that. And so this makes sense to me. But this is not going to work. We're not going to get 1 for this, although it's ideally what we want. And if the 3 and 7 values will not go to 0, that's what we're finding for sure. And the 4 and 8 values will not go to 1. What we get here is 0.25 and 0.75. Whoops. And same here, 0.25, 0.75, and then slowly they'll resolve over time to better values. So if I make this that and this that, it should work. I think the test will pass. Although I feel real dirty writing that code. It's still asserting. What? Oh, whoops. Oh, right. Yeah, I have to have different ones for each. It's not. Right. 3 and 4. 3 and 7 can't go in here. So I could do the same thing for this. I want to get some tests that pass, but I'm not sure this is the right test to have. But I just want to see that what I'm getting here is expected. And in retrospect, I get why this function is doing what... Why are you telling me that? In retrospect, I understand what's going on here. This is going to be 0. Okay. I just don't like it. Oh, come on. We're so close. What's going on? 3 and 7 are not 0.25? Oh, 3, 7. Yeah, you told me that before, Eric. I just didn't get it. I think I get it. It's more like, it's not exact like I want. But it's honestly, it's working as expected. It's just not exactly what I want it to do, but it's doing it. So So I'm gonna clean this up, and I have to leave in 15 minutes now. I've wasted all my time trying to understand moving averages. So sorry. It's all this formula here that is not going to give me the resolution that I wanted unless I keep track of every value over the window, and there's no need to do that, right? Because we're going to see a lot of values. So we're not going to do it. We're going to keep it the way it is. And we're also going to keep a list of, well, I'm going to do the overlap duty cycles. We didn't even get to overlap duty cycles this time. We just introduced the period. So we'll do overlap duty cycles the next time and hopefully actually do some graphics so we can show overlap duty cycles here along with active duty cycles because they look different. They look quite a bit different. It looks a lot more interesting with topology. I'll show you one thing about active duty cycles before we go. Excuse me, overlap duty cycles. Something I threw in here. It was in behind the scenes things. So here's an interesting one. So here you can see overlap duty cycles on the right. Oh no, those are boost factors. Which one of them was overlap duty cycles? That's boost factors. Where's the playlist? Okay. Hi, so one of these had overlap duty cycles. Was it this one? I think it might be this one. Yeah. Okay, so see there's a button here that says show ADCs, show ODCs. So I will click the ADCs first. These are active duty cycles. It looks a lot more interesting with topology. So this is just activity, and the overlap duty cycles look different because they're tracking, it's averaging the overlap score over time. So here's what that looks like. So as you can see, it's similar, right? It's the same sort of shape, but just but different. It's the same shape but different. We have to keep track of both. I think for boosting, I haven't gotten into the code yet that requires both of those, but I know you have to keep track of both, so I will be showing both. And I had the impression that the active duty cycles were going to be like a percent of activity, on and off activity, and the overlap duty cycles would be a count, average count of an overlap score. I thought that was the case. I might be wrong about that, but we'll find out. Obviously, we'll find out. Okay, I'm going to take off. Sorry we didn't get as far as I wanted to today, even after 2 hours and 20 minutes of streaming. We will continue on Friday, and I might do a little bit of behind the scenes work so we don't run into any issues like we did today, so that everything works. Anyway, I'm not going to commit anything right now because I might go push this stuff to a branch, my remote branch, but I'm not going to commit or create a pull request because I don't think this is nearly ready to push or anything. So it just is what it is, right, Falco? It is what it is, which is the most meaningless statement you can say. Take care, everybody. I am going to take off, go pick my kid up from baseball camp. Have a wonderful day, everyone. Thanks for tuning in.